Now in this video we will be looking at the geometric meaning of the vector product. Now I know this vector something looks a lot quite of it looks like a big deal, but look, all that matters here is getting the concept, okay? And that's what we are going to do. Now sit back and just give me a couple of minutes of your time, okay? Now having the parallelogram, okay, so now let me try and draw it as accurate as possible. Okay, I think this is good enough, right? Now let's label this side, let's call this side B, and let's call this side A, right? And also let's call our vertical line, over here, and let's call this K, right? I wanted to use H, but so that you not confuse it with the hypotenuse. And remember, there is a theta over here, right? Now we all know that sine is equal to the opposite over the hypotenuse, right? Sorry, sine theta is equal to the opposite over the hypotenuse, from so, right? Sine opposite hypotenuse, right? So this is equal to what? The opposite side, which is K, on the hypotenuse, which is the magnitude of B, right? Now B is the vector, and the magnitude of B is actually representing the length of the vector, right? So now we can derive that K is equal to what? K is equal to the magnitude of B sine of the angle theta, right? The magnitude of B sine theta. Now, as I said, this is a parallelogram, right? And the formula for finding the area, so now the area of a parallelogram is equal to um is equal to the vertical side, which is represented by K, and the product of the horizontal side, right? The horizontal side, and the horizontal side in this situation is what is A, right? So we have the product of K times the magnitude of A, right? Now we have derived that K is equal to what? The magnitude of B sine theta, right? So the area is now become the magnitude of B multiplying the magnitude of A sine theta, and this is the expression we get for the area of this parallelogram. Now take note, this is equivalent to what? This is equal to what? The cross product between A and B, right? Because A cross B is equal to the magnitude of A multiplying the magnitude of B sine theta, right? So now this is equal to the cross product of A and B. Now this is our second derivation. The third thing we are coming to derive from this is that a parallelogram is actually made up of two triangles. Sorry, this isn't accurate. It's made up of two triangles, right? So let's divide this parallelogram. Now, this means that to find the area of one of these triangles, we have to multiply this by half. And this gives us the formula for the area of a triangle when the cross product of two of the parallel sides are given, right? So now the area of triangle is equal to half multiplying A cross B, and this gives us our final expression. Thank you all for watching. We will be solving examples using these formulas in subsequent examples. Please subscribe. This is Teach Me Maths. Love you all. Bye.